Hello. Today we will discuss about waves, mainly light waves, propagation of waves, and how the waves will superpose with each other. So to start with this, to get some idea about the wave propagation, we will discuss about Huygens principle. Now to discuss Huygens principle, in simple words, Huygens principle explains how we propagate by considering each point on a wavefront as a source of new waves, which will spread out in all directions. So there are a number of terms which need to be explained here. So one of the important terms is wavefront. Then another thing is wave propagation. Okay. So let me just start about the light waves. So to discuss about light waves, first we need to think about the atomic model, the simplest form of atomic model. Now in this picture, it is shown that nucleus and electrons are surrounded. When you supply some energy, the electron moves from ground level to excited level. And when they are transiting, this electron is transiting from ground level to excited level, it releasing one photon. Now we can see one photon is released. You can see it is moving in this way. Photon. Now this photon, when this will interact with the loosely bound electron placed inside the material, so then this will start oscillating. The electron will start oscillating. When the electron starts oscillating like this in simple harmonic motion, one can think about, this will produce some electric field. So in one direction there will be time dependent electric field. As there will be electric field, in the perpendicular direction there will be magnetic. So now in this picture it is shown that in one direction electric field is fluctuating in blue color, and in the perpendicular direction there will be magnetic field. Both are vector components. So the energy, the resultant energy will move in the perpendicular to both of us. Now there will be large number of photons released from the material. So this will act as a source of photons. And photons are interacting with charged particles, so large number of photons and large number of electrons are interacting, so large number of electric fields are fluctuating. So this gives you a continuous flow of energy in this. So here, this blue color, on the left hand side, it is considered as the light source is at infinite distance. And you have a small slit in front of it. So as an infinite distant light source is available, so the wavefronts are parallel. So on this parallel wavefront, one can think about the electric fields are fluctuating. Any point you can think about. So each and every point, it really explains the fluctuation of electric field. So obviously in the perpendicular direction, there will be magnetic field and wave is moving in the forward direction. Now, when you have a obstacle just in front of us, you have a small obstacle. So the majority of the electric fields are obstructed by this portion, but a small portion of electric field can move in the forward direction. This basically known as secondary light sources, because here the individual electric fields are acting as a light source. So this explained by Huygens. Now one can think about a source of energy, light source of energy, which can move in the forward direction in form of a wave. So now onwards, when we think about light waves, so we need to think about a source, something like this, and energy moves in all directions. So this yellow dot, so one can think about light source, yellow light source is here, and the yellow dots are moving each time in all directions. They are only considered forward direction, but it will move in the all directions. Now, if you want to connect these dots, this looks something like this. This is shown over here. So in geometrical optics, these rays, these are considered as rays. Okay. Now comes the case of fluctuation of the electric field. Now it's also explained one of the important things, that if they are fluctuating faster, so obviously the shorter wavelength will be observed, shorter wavelength light will be observed. So high frequency. And in another case, if the fluctuation is of low frequency, then the frequency of the wavelength will also be very low. So this is the picture which is shown. So this is the faster fluctuation. So shorter wavelength, higher frequency, and if this is of slower, so the higher wavelength and lesser frequency. It is shown. Now, what is the idea about the wavefront? We have just mentioned about the thing. What is the idea about the wavefront? So one can just think about a portion here. So you can just connect those points over here. You may just connect those. So let me just get a different color. You may connect those points. Now these points are basically explained by the fluctuation of electric fields. Each and every dots are explaining fluctuation of electric fields. Now, for this region, just considering the electric fields are fluctuating in same phase, then this portion will be considered as a wavefront. Now, this can be considered as a primary light source, and from this part, when waves are producing, they can be considered as a secondary light source or secondary wavefronts. Now, wavefronts are of two types. One is spherical wavefront, another is plane wavefront. So, what is spherical wavefront? So, when source and screen is at finite distance, then you have a spherical wavefront. So, this particular picture can be extended in 3 dimensions. So, circle, the connection, dot connection gives you circle in 3 dimensions. This will obviously be a spherical. So, one type of wavefront is spherical wave. And there is another possibility which is known as a plane wavefront, when source and screen distance are infinite. So, you can just think about a smaller portion of the circular wavefront. So, this can be considered as a plane wavefront. Or one can think about a very big sphere, a very big sphere. So, the part of the sphere can be considered as a plane wavefront. So, this is the consideration. Right? Source is at infinite distance. Now, here, this distance is finite. So, this becomes a spherical wave. Now, these are the pictures explaining spherical wavefront and plane wave. Secondary wavefront, just you have mentioned this thing, that from a primary light source, the electric fields are fluctuating. If you have exposed in front of a small slit, then here few number of electric fields are fluctuating. So, now individual electric fields are acting as a secondary light source. So, those waves are moving from this point, they are considered as they can be considered as a secondary wave. This is the picture. Now, there is another important part. So, waves are moving from light source, waves can move in a circular form or in a plane form. But now, if you have two sources placed side by side and they are interacting with each other, so what will be the effect? So, this explains the idea about diffraction or interference. Now, to explain diffraction and interference, one can consider a simplest picture like this. This is a double slit experiment. Now, here you can think about a light source. Okay, so this will be considered as a primary light source. It's a primary. Okay. Now, from here, photons are really producing electric fields, fluctuating electric field, magnetic field, and the wave proton. Now, it is just exposed in front of it, just two slits. These two sections are two slits. Now, here, the secondary light sources are produced, secondary wavefronts. What is secondary wavefront? Fluctuation of electric field. Now, these two waves, now from this part, it can produce one wave, and from this part, there will be another wave which is going to be followed. Now, they will superpose with each other. Now, when they are superposing with each other, so the two electric field fluctuations from this one and from this one, so they will interact with each other. This gives the idea about the case of interference and diffraction. Now, depending on the condition, there will be interference, and depending on some other condition, there will be diffraction. Now, in simple words, the superposition of waves can be explained by these two simple things. Now, what is superposition? When two or more waves cross a point the displacement at the point is equal to the sum of the displacement of the individual waves. The individual wave displacement may be positive or negative. If the displacements are vector, obviously they are vector, the sum is calculated by vector. So what you have to do? Just consider two different pictures. Here we have a single source, single energy source, and energy moves in all directions. Okay, and this part are the wavefronts. So one can just imagine a source which is giving you waves in the forward or wavefronts in the forward. And what is wavefront? When electric fields are fluctuating, here electric fields are fluctuating, they are fluctuating in same phase. Now here we are considering two different light sources or two different sources. These are also source of energy. Now from this part waves are moving and from this part waves are also moving in the forward. So here also electric fields are fluctuating, here electric fields are also fluctuating. Now there is a possibility of interacting between the electric field from the source 1 and source 2. And when they are interacting, they will produce the interference or diffraction pattern depending on the phase condition. Phase between the two electric fields or phase between the two waves. So mathematically one can consider wave y1 as a function of position and time, y2 as a function of position and time, and what will be the resultant form? This will be simply addition of y1 and y. A simple picture which is explaining this. Now, to explain the thing, we are going to use a simple phasor diagram, a phasor method to explain this. Although one can use a mathematical addition method, so we will consider both of them. So, a wave, or in this case, you have electric field fluctuation. So, this can be explained in a simple way. One can just think about a wave equation. Y is equal to A sine omega t. Let's say this is y1, and we can have another wave as y2 is equal to A sine, inside the bracket I am writing omega t plus. So what we are doing, we are considering two electric fields, they are fluctuating. Okay. Just consider this is the fluctuation of electric field. Just we can think about energy starts from this point, it moves in this direction or this direction. This is the maximum distance it can cover and it comes back. Then again you have another electric field which is fluctuating, they are identical. The main point is also at same position, they are actually identical. Only difference is they have different phase values. What is the phase value? So just think in this case the one fluctuation starts from this point and another fluctuation starts any other point except the main. Say it starts from this particular point. So this difference will be considered as phase. Okay. So if it starts from this point, one can consider this is plus phase and this can be considered as minus. Now here you have two waves. Two waves are fluctuating. A sinusoidal thing one can consider. Their amplitude values are A. Okay, and they are a phase difference of 5. Now, to have a phasor diagram, one can just think about its amplitude. So, I have taken three waves. Just consider the first wave in green, you have an amplitude something like this. As much as the amplitude. Now, this is given by this vector. Okay, this is the vector which explains. And you have the blue one. Here you have a huge difference between the green wave and the blue wave. So its amplitude is lesser. So this is explained. Now you can just think about the third one. Third one and the first one having almost same amplitude value, same length, but there is some phase difference. The phase must be explained by the angle. So what will be the angle? This will be the shifting position from its. Okay, so from its dotted line, say the phase difference is 90 degrees. So the yellow line must be somewhere. If this is 30 degree, this is 60 degree, 45 degree, one can easily draw. So if you want to add the waves, wave 1 and wave 2. So it's simply the addition. They are in same phase. So their addition will be the green plus blue is the resultant. The total length is this to this. If this is A1, this is A2, the total length is A1 plus A2. But in the second case, just to think about, we are considering two waves, first one and the last one, first and 3. So this is the green one, and you have some phase difference between green and yellow. And this is the resultant. Okay, in between first. Okay. Now one can calculate, by using this, one can calculate what will be the resultant amplitude. Now for the superposition case, one can use. Now we can take a simple example of a special case of superposition of light, which is known as interference. So what happens in case of interference of light? So in this case, we are going to consider two waves, okay, two sources of wave energy, light wave energy. They must be identical. So we are assuming their amplitude values, their wavelength or frequency, and the phase values all are similar. What are those? Amplitude, wavelength, frequency, and phase. They are equal. If they are equal, one can think about one electric field fluctuating here and another electric field fluctuating here for two different sources. They are of identical. Now, when they will interact, what will be the effect? Now, in simple word, one can just think about in terms of vector. In terms of vector, one can just think about this length A and A. Both are of equal amplitude. This will be A. Phase values. Okay, for simplicity, we are considering the phase value is equal to 0. So the simple addition will be A plus of A. So what will be the resultant amplitude? Resultant amplitude is given as A. Okay. Now there is another possibility. If phase value, it is one case this is 0, another case it is 180 degree. If this is 180 degree, what will be the form of this vector diagram? So this will be simply given as first wave and 180 degree. This is at 0 degree. So somewhere this will be 90 degree. So the 180 degree will be something. This is 1A. So what will be the resultant one? The resultant can be simply given as A. So what happened in this case? The resultant amplitude when the phase value is equal to 0 it simply becomes 2 into A. Resultant amplitude is 2 into A. And in this case the resultant amplitude is equal to 0. So one can think about after superposition you can get one wave. His amplitude are of 2 depending on two different conditions. In one case this will be 2A, the twice of addition of 2 amplitude, and this one is A minus. Now just to see this thing by using some mathematical expression. Now we are assuming the wave as A sin omega t and this is also A sin omega t plus. Now when you add this thing, it simply can be considered as a sin C plus sin D. So in this is sin C plus sin D, so this can be written as 2, A can be taken as common, okay. So sin C and sin D, so this will become sin C plus D by 2. So what is C plus D? C, this is omega t, D is omega t plus 5. So this will become 2 omega t plus 5 divided by 2. So 2 omega t by 2, this means omega t plus 5 by 2. Plus 5 and multiplied with cos. Cos is equal to C minus D by 2. So C minus D. So omega t and omega t will be vanished out. This will be minus of 5 by 2. We know minus of 5 by 2, cos minus of 5 by 2 is equal to cos plus of 5 by 2. So there is no difference between cos plus minus theta and plus. Now so you have this expression here. Just rewriting this one, 2a and the cos term. 2a into cos term. Sin omega. So this part is the time independent part. And this part is the phase part, also known as the time dependent part. The time independent part normally considered as a amplitude of the wave. So what is this amplitude of the wave? In the last case you have considered this is R. Now depending on the phase value, if this is 0 degree, so now this will become A plus of A whole square. This is twice into A. Now the same concept can be considered as when this is 0. So when cos 0, we have cos 0, this becomes 1. So the whole factor becomes 2 into A into the maximum amplitude. Now there is another case where R it becomes A minus A. What is this condition? A minus in phasor diagram it is observed that when the angle between the phase angle it is 180 degrees. So 180 by 2, this is 90 degrees. So cos 90 is equal to 0. So in this case the resultant amplitude is. So when two waves are superposing at two different conditions, in one case the phase value is 0 and another case phase value is 180 divided by 2. Now we have a maximum point and you have the minimum. What is this maximum and minimum? So in case of interference, the condition of maxima when intensity becomes maxima, this is known as constructive interference, and this is given by if this is amplitude, so this is amplitude is A plus A. So the intensity is given as in this case intensity is given as this is equal to 2 into A whole square 4 A square. Sometimes it's called the I max, intensity maximum. And intensity minimum, obviously this is equal to 0. So the intensity maximum is known as the constructive interference and intensity minimum is known as destructive interference. Let me just see. Now here, in simple way, one can consider it starts from its primary light source. It's divided into two parts. So as they are divided, their amplitude value, their frequency values are same, and we have just fixed it. Their phase values are either 0 or constant, 0 or 180 by 2. So they will superpose, and when they are superposing, the electric fields are fluctuating, they are interacting with each other, so they will give you either maxima or minima. So the maxima in this case is a very bright light section, and minima there is absence of light, so this is dark. This is given as black. And this is the picture, which is a phasor diagram, what we have just explained. We have two amplitude, two waves, they are superposing, it becomes 1 plus 1, A plus 1. In another case, this will be out of two different phase values. So this is A minus of A, see. Now in which condition the phase values is equal to 0 or constant. This condition is known as the coherency condition and the coherent light source. So what is coherent light source? Coherent light sources or coherent source of light are those sources that emit a light wave having same frequency, same wavelength, and they are in same phase. Okay. And they can be considered as, or they can be considered as a constant phase difference. A coherent source form sustained by interference pattern when superimpose of wave objects and the position of maxima and minima are fixed. So if you fix the phase values, obviously if you are taking from the same light source, its amplitude, wavelength and frequency will be same, and if you are able to adjust the phase values, you will be able to get the coherent light sources, and if you have coherent light sources, this will give you interference. In interference, you will get maxima and minima. So there are two types of coherent light sources available. One is known as temporal coherency and another is known as spatial coherency. So temporal coherency is the time dependent coherency and the spatial is the space dependent. Now in simple way, one can just consider two waves, just taking a different color. Just think about two sinusoidal waves are moving. Now one can think about this thing and get it. Just a good pattern of sinusoidal wave. Just consider they are identical. They are not just consider they are identical. Now you can just think about another node over there. Now, in one point electric fields are fluctuating. Here also electric field is fluctuating. Okay. Now with time it's covering some distance. The the point comes, it's the same point after covering some distance, it comes from here. This also comes from here. And they are maintaining their phase value. So initially there was no phase difference between them. And again also when they comes here, there is no phase difference. So at certain time, say at time taken, say Tc. After time Tc, so there will be no phase difference. So then we will be consider these two waves are coherent in nature. Which type of coherent? They are temporal. Now, one can think about spatial coherence. So again the same concept, you have two waves, they are fluctuating. So just imagine this wave, these two electric field fluctuation on an imaginary plane. They are of same plane. Okay. Now this plane comes after some time, the planes cover some distance. Okay. So this distance is represented as LC. Okay. So even after crossing some distance, the same plane, two fields are fluctuating at say after covering some distance, they are maintaining their phase value. So they will be considered as a spatial. Now what will be the relation between LT and LC? It's simple relation. S is equal to Vt. We are all familiar with this relation. S is equal to Vt. S is the distance covered, V is the velocity, this is the time taken. Now in this case, S is given as LC. So this relation is given as LC is equal to velocity. We are talking about light, so light moves in a velocity of c. And time taken, in this case, this is EC. So LC, sometimes called the coherence length, EC is known as the coherent time, and C is the velocity. Okay, so these are the two different types of coherence, temporal and spatial. Now, the cases of interference or coherent source, how we can produce coherent sources. So, there are two ways to produce coherent light sources. Number one is by division of wavefronts. Now, in this case, one can just refer the case of Young's double slit experiment or Lloyd mirror experiment or Fresnel biprism experiment. So, in this case, if you are considering the double slit experiment, what we have? You have a single light source, waves are coming, and you have just placed a slit, one or two slits. They are divided into waves again. So here, from a single wave, we are dividing into two waves, two coherent light sources. So in case of Lloyd mirror or in case of this biprism experiment, we are also dividing the wavefronts, and we are forming two coherent light sources. And there is another case. In this case, this is known as the division of amplitude. Now, division of amplitude is only possible when you have the case of reflection or refraction. So, there will be absorption of energy. So, the absorption of certain energy. So, this will give you the loss of some amplitude. So, in case of Newton's ring experiment, when light falls on a plane of convex lens and it passes through the air frame, so there will be number of reflection and refraction occurs. This decreases the amplitude value. But this amplitude value decrement is not very large, it's a very, very small decrement or variation with the amplitude value. But still, they are maintaining their phase value. In all the cases, this is maintaining their phase value. So, they will be able to produce a coherent light sources, and when they are superposing with each other, this will produce interference. Now, simple way, what we have discussed here, we have discussed about the wave propagation. So, how wave was propagating? This is following the Huygens principle. So, photons are produced, they are interacting with charged particles, it starts fluctuating in electric, in simple harmonic motion. This gives electric field, in perpendicular direction there will be magnetic field, and 3 dimension they are forming wavefronts. This is the picture which explains the formation of wavefronts. So, what is wavefront? The combination of some points, electric field fluctuation, they are in same phase. When they are in same phase, this can be considered as wavefronts. Now, wavefronts of two types, spherical wavefront and plane wave. Now, then the idea about the superposition of light, interference or diffraction. So, in case of interference, what happens? When the coherency condition was satisfied. What is the meaning of coherency? Their amplitude, wavelength and phase values are equal. When they are superposing with each other, so this will produce the maxima and minima conditions. only maximas and minimas, destructive and constructive interference. So we have also discussed about the types of coherency and how we can able to produce the coherent light sources. So different coherence are temporal coherence and spatial coherence, and the next one is division of wavefronts, by which one can produce coherent light sources, division of wavefront and division of. Now here what we have talked about is the phase condition is either 0 or constant, and we have just considered only two cases, when they are at 0 or when they are at 180. But still there are another 179 combination left. Okay. So if waves are interacting are of other phase values, so this will be the case of diffraction. Okay. So in the next few lectures we'll talk about diffraction. Thank you.